right, I hope you are clear as to what standard deviation means so that we can do this and be happy. The area under the normal curve is 1. That means that that whole thing, there is 100% of the data. So we tend to use probability a lot with this too. Okay, so what we want to talk about is what a z-score is. A z-score is the number of standard deviations above or below the mean. So it's just giving you the standard deviation. So if I tell you the z-score is 2 plus 2, that means we'd be right here. That would mean it would be 2 standard deviations above the mean. So that would be a positive 2. If I say it's negative 3, the z-score is negative 3, that would mean it would be 3 standard deviations below the mean. So z-scores are just measures of standard deviation. If it's positive, it's above the mean, and if it's negative, it's below the mean. That's it. So the formula for a z-score is the data value minus the mean divided by the standard deviation. So that's how we find out what the z-score is. So let's just do a couple so you can understand. So a college entrance exam was designed so that scores are normally distributed. Okay, that means it has this normal curve here, meaning most of the scores are right around the mean. And the average is 500, and the standard deviation is 100. So what that means is the mean is 500. It means mean goes right there. And every standard deviation up is 100. So this would be like 600, this would be 700, etc. So from that you can probably tell where 700 lies, what I just said. But let's just use our z-score formula for this. So the z-score formula, the person's z-score is equal to, if they got a 700, we simply subtract the mean and divide by the standard deviation. So 700 minus 500 is 200, so this is 2. So that means 700 is 2 standard deviations above the mean. Means they did pretty well. They scored right here in the percentage. Okay, and that means you see that there's not a whole lot of people right there. The graph is pretty low, so that means 2 standard deviations up is actually quite good. 400, so let's look at 400. This person's z-score is equal to the data value minus the mean divided by the standard deviation. Remember, this is where I got the mean, and this is the standard deviation, in case you were wondering. So this is 1, or negative 1. So it's negative 100 over 1. So it's negative 1. So it says negative, so that means it went below the graph, the mean. So the mean is right here. The 0 is always the mean, and it went below it 1 standard deviation. So 249. Same value, so the z-score is equal to 249 minus the mean divided by 100. So when we do that, we get negative 2.51. Make sure you do that in your calculator and you're dividing at the right moment. So negative 2.5 means they went below the mean. They're this way, and they're right about here, about negative 2.5. So they scored pretty low. Depending on, well, if it's a college entrance exam, yeah, they scored pretty low. So 734, our z-score is 734 minus 500 divided by 100, and that's equal to positive 2.34. So these people scored 2.34 standard deviations above the mean because it's positive. So what we do is we compare z-scores. We look at them and say which one is better. Just so we have 2 different situations and we can compare them then. That's what z-scores allow us to do. So say there's a math test. The math test has a mean of 70 and a standard deviation of 8, and an English score of 74 and a standard deviation of 16. Well, let's say you got a 78 on both of them. Which one are you better at? So it seems like relatively strange information that we shouldn't be able to compare, but we can because of z-scores. So if our z-score, if we find the z-score, we figure how far above or below the mean that you got. And the higher above the mean you are, the better you did. So if you got a 78 on the let's do math first, because it is first. You got a 78 on the math test. We had a mean of 70 and a standard deviation of 8. So that means that you got 1 standard deviation above the mean. Okay, so if then we do English, your z-score is you got a 78, the average was a 74, and the standard deviation was 16. If we do this, we get 1/4 or 0.25. So you did a whole standard deviation above the mean on the math, so a higher z-score means higher standing, or you did better, relatively speaking. So you did better in math. Okay, so this one. So 2 people want to know who's smarter. Okay, who is it? So one person took an IQ test and one person took an SAT. We assume that the mean of the SAT score was 1500. Okay, I definitely pressed the wrong thing there. Was 1500 with a standard deviation of 300. Well, Michelle took that test and got a 2070. So let's figure out Michelle's z-score for the SAT. So her z-score is 2070, her date, what she got, minus the mean, divided by the standard deviation. We do all that, that is 570 over 300, which is 1.9. So she did 1.9%, not 1.9 standard deviations higher than the mean. All right, so then let's look at Eileen. We'll do her in a different color. So Eileen took the IQ test, and she got 129 on it. That's her score. The mean was 100, and the standard deviation was 15. So Eileen's z-score for her IQ is 129 minus 100 over 15. So when we do that, we get 29 over 15, which is 1.93. So she got 1.93 higher on the IQ test than the average, 1.93 standard deviations higher. So that means that she, Eileen here, has a higher, scored higher than the average and scored better than Michelle. So technically, according to Mensa, Eileen is more intelligent. For the way Mensa, it's the way Mensa decides, not me. Okay? 2 versions of a standardized test are given. For example, 3, so this one throws a little, hitch in it. Seems easy, we're finding the z-scores, but this one's asking, 2 people took the SAT. Joanne got a 510 in April. Okay? But Steve took the May version. What score would Steve have to make to score the same as Joanne? So this is a slightly different version of the problem, so let's figure out Joanne's z-score. So Joanne got a 510. And the mean was 480. This was in April. So her z-score was 1.25. Now I want to know what Steve has to get. So we don't know Steve's score, but we do know we want it to be the same as Joanne's, relatively speaking. So we want to get her and him to get the 1.25 standard deviations above the mean. So his test in May had a different mean and a different standard deviation. So in order to do this, we have to use the formula slightly differently. Okay? So then we solve this. We don't know what his score is, but we want to find out. So we cross multiply and we get 25. I'll write it up here. 25 equals x minus 510. Add 510. So in order for Steve to claim that he got the same grade or the same SAT score as Joanne, he would have to get a 535 on his test, where she only got a 510. So that's how this works. So we can compare, contrast different z-scores. Have a good day.